All right, well, welcome everyone to the November 29th, what year is it? 2022 SIG Node meeting. We didn't meet last week due to the US holiday, but a number of items on today's agenda. I think we'll go through the first one here, which is a kind of a discussion on merits of exposing a secret path in the Kubernetes API for running pod. Is the person who put this on the agenda here available to talk through their use case and more? Or maybe we can have some discussion on pros and cons on that.
I believe that's me.
Cool.
Should I share my screen or?
It's up to you. I mean, the floor is yours. I think I clicked through the issue. I think anybody else can probably click through it. If you have other material you want to show beyond the issue, that's fine too.
We can just start off from the Kubernetes issue. Could one of you, I don't know if I have the permissions to share my screen.
You do, no.
Oh, okay. In that case, yeah, let me try this. Okay, hopefully you'll see my screen with the Kubernetes issue.
Yeah, looks great.
It says, oh, cool, okay. Yeah, okay, just a quick introduction. I'm a software engineer working on Cilium, and I'm here to socialize our feature request to expose pod cgroup path in a standardized way. And we believe that it will help us and others in the community to simplify and support their use cases. So yeah, before we get to the pros and cons with the existing ways to retrieve pod cgroup path, let's just quickly go over some of the use cases. I believe we have context around what pod cgroup paths are, so I can skip that part. Is that okay?
Yeah, I think everyone's, maybe the only thing that you could clarify here is if you actually want the pod cgroup path, or do you want every per container cgroup path in that pod as well?
Pod cgroup path is a good start, and well, I guess more information is always better. So if getting a secret path at the container level is possible, then yeah, that's even better.
For the Cilium use case though, is it just the pod cgroup path you need, or do you actually need the per container path? So
right now we are using per container path, but just using, it should suffice for our use case if we get secret path at the pod level. So that's the Cilium use cases. I've listed other open source projects here. I don't contribute to these projects, so I'm not intimately familiar with this, but I believe they are using pod cgroup paths for like variety of use cases like monitoring, statistics collection, and so on and so forth. And for Cilium, we use eBPF for load balancing, policy enforcement, and other use cases, which is where we require pod level secret path. So yeah, that's the thing on use cases. And so these are some of the ways we can retrieve pod cgroup path. And every approach has some cons. So do you want me to go over these, or do people already have context here?
I think, I mean, I know I have context. I don't know who else, if anyone wants to speak up. I think it's fine to go through it. And if we could maybe time this discussion to about 10 minutes, and we can either choose to make the best use of the discussion on merits of doing this, or what we want to do as next steps, or like get everyone on the same page. We can see as you feel. We can go either route, I guess.
Okay, yeah, I guess if you have only 10 minutes, then I would suppose that I have listed all the information on the issue, so people can just reference this later. But yeah, the merits are, these are all the projects. This is not an exhaustive list, but it gives a feel for variety of use cases involving pod secret paths. And so if you click on these links, it should take you to the open source source code, where you can see how every project has its own way of retrieving pod secret paths. So there is no like a clear standard way. And then these are the limitations with each of these approaches that these open source projects use, including Cilium.
If it's okay, can I ask some clarifying questions then? So
Sure, yeah, go
one of the
ahead.
reasons that I could see wanting to put the C group path on the Kubernetes API and in the pod status, let's say, and maybe at either container or pod level granularity, is that you have a control component not running local to the node that needs to do something with that information. So in the Cilium use case, do you have, who is actually watching that pod resource, and is it running on a per node basis, or is it running centrally on some control component?
Yeah, so with Cilium, we are following this third approach, which is crafting based on patterns. We do it on per node basis. So at least at this point, we don't have like a centralized component where this information is needed, but it could be possible that we have future use cases for that.
So does the Cilium, let's say it's a daemon set pod here, it runs on every node, that currently watches all pods bound to that node, is that right?
Yes, exactly.
Okay. And then is there anything related to the Cilium flow for when that, I'm trying to think, like today the pod C group could change if the sandbox is torn up and down, I guess. And then obviously for container C groups that can change with the life of a container and a restart policy. What's the impact of that type of thing in the Cilium use case if the C group was to change?
Yeah, so yeah, if you take an example of like, for example, if a container is in like crash loop, it's getting recreated. So this container ID would be different every time the container comes up. And in this case, I'm not sure if the pod ID remains the same, but yeah, if there is a change in pod C group path, then we would want to get notified about the updated pod C group path.
One question I have is like, aren't these actions that are adding hooks or anything in the C groups level, like inline, if you try to do it offline, it's going to be racy, right? You can't wait for the status to be updated and go and do something, because by that time pod is already up. So whatever network policy or anything you want to inject is kind of racing with the pod running. So what I'm trying to say is like, isn't this something that would run as part of your CNI bring up portion of the pod?
Well, I mean, yeah, so we don't have access to this information in the CNI workflow either, because the secret paths are not exposed to whatever the CRI spec is.
Yeah, so I think that can be passed from the runtime to the CNI invocation though.
Yeah, I can't remember offhand if we create the pod C group first or we create the pod C group after the CNI says success.
It is before. I mean, kubelet creates it already, and then we bring up the pod on the runtime side, and we call CNI as part of the runtime flow.
Yeah. Okay.
So I can give a data point here. When we were evaluating this CRI gRPC interface approach, we noticed that as part of the sandbox, this field, like the container hasn't been created yet, because networking, only after networking is completely set up, does the kubelet goes ahead and instructs the container runtime to create this. So what we noticed is as part of the sandbox spec, we didn't have access to the C groups path information.
That doesn't seem right. I guess we'll need more details, because
Sure,
kubelet,
yeah.
yeah,
I'm not an
kubelet
expert
creates
in this area, so yeah.
Yeah, and then so I think at a high level it makes sense that maybe a CNI implementer wants to be able to know the pod C group that will contain that pod on a Linux host. Maybe just one thing we can do, and probably the outcome on this is to maybe write up to get more to what the core root use case is that's needed. One of the things that would give us pause about putting the pod C group path in a status field is it is obviously Linux specific. Two, I guess, will we be expanding it to like what active C group controllers are on or off over that pod? Three, things doing it with like on a per container basis, particularly if those C groups get created and destroyed. As Mernal noted, that the information would be kind of latent if we have to checkpoint it back to Kube API every time. And so we have to be careful about that. And then I guess some other things that I'm curious if have come up in your CNI use case would be the intersection with this and other runtimes that may handle containers differently. Like, so any intersection with Kata or, oh, I forget the name. What's the name of the Google project you all have done?
gvisor.
gvisor. Doing that on a per container basis felt really problematic to me, but scoping it to just the pod basis doesn't seem to do enough to be expansive to the monitoring use cases you talked about. So what I'm wondering is like if we can just narrow the use case to be CNI, ensure the CNI has the right information it needs at CNI startup rather than having to put too much more into the actual pod API itself is kind of the tension I would see. Do you have do you have a preference on that? Like, is it fair to just say you would like to know the sandbox location at CNI construction time, and that would be sufficient?
Yes, that sounds really appealing because going back to, I don't know who was the person who mentioned about the RACI conditions. That's definitely possible, especially when we install these eBPF hooks that are invoked at a socket calls, like for example, whenever a pod makes like a connect call or something, it's important that we have this information available before any network traffic is passed through a pod. So getting access to this information as part of the sandbox container runtime sounds like a great idea.
Okay. So would it be okay maybe as the next step if we maybe if we relabeled this issue as the core use case here, which is coming up, which is saying enables CNI integrators to know the bounding C group of a pod. And then before coming to this particular implementation route, we could also look at the other alternate route, which would be what could we do to ensure you have this information as a part of the CNI setup. And then maybe we can come back and evaluate pros and cons on either. One particular thought as an API change is going to be a very long process for you as an integrator versus the more we can do independent of end user facing API. I think maybe that would be a quicker path, but that'd be one of the things we could evaluate when looking at various options. And is this the only reason your CNI would need elevated privileges, or are there other, does this actually help you reduce privileges entirely when getting this information?
So right now, since we're following the third approach, we don't have to elevate any security privileges. But at the same time, there are limitations in supporting like different kinds of environments.
Okay. I guess the last thought we could ask if we want to make the pod C group taxonomy laid out by the kubelet like a stable, dependable API. That's just like a documented convention. The paths you use now have been in place since a very long time now, and we haven't had strong reasons to change them that I can think of. But there are users who do change the C group parent path, I think. So anyway, that's probably another thing to think through, but is that next step as basically like, can we scope this to just how to make sure the CNI has this information and then put this option among one of many, and then we can come back and revisit?
So I don't fully understand the implications of doing it at the CNI level versus like exposing it as part of the status field. You did mention, like, for example, if it was default to CRI, then it can be a long process. So can you elaborate on that a bit?
I'm saying if we put any changes into the end user facing API, like to do it, like it's just to add a new field to the pod status, right?
Mm-hmm.
You're looking at 3 months, 4 months to get that into an alpha phase. And then you're looking at, it's basically a year activity is what I was just trying to call out. And it could be that there are other faster ways for us to get you dependable ways of getting this information. Just changes to the end user facing API are given a lot of scrutiny is basically how I would phrase it, because of the graduation process they need to go through. And it's possible that the alternative path of seeing if we can do something in the CNI bring up flow is a equally valid and faster path, and doesn't make users look at the Kube API as a source of truth for this information, particularly if it rapidly changes. So like crashing pod sandboxes, we wouldn't really want to go and drive a lot of write rate back to the Kube API server, right? So in general, I think there's probably going to be a lot of hesitancy to report this as a status field in the pod API versus can we find other ways of getting you this information stably outside of the pod API? And maybe Mrinal or Dawn or others chime in if you.
Yeah, I think I agree. I think like this seems like low level information that seems weird to expose at the API level. So if we can get it to you down at CNI setup, that stays at the level it needs to be at.
I think there's the suggestion on the Mac, or maybe the menu, and yeah, just on the local node. And sorry, I was coughing. So the CRI implementation can pass to the CNI at the runtime. So that would be solve your problem, right?
I just want to add one other, sorry. I just want to add one other idea I didn't hear raised yet, which is NRI. So I don't know if you're using Containerd or Cryo, but Containerd has this concept of NRI that's been a little bit newer, which allows you to kind of hook into container creation and get back kind of events, right? So you can get kind of a callback when like the sandbox container started. And using the sandbox container, you can extract out the OCI spec and get the C group path through that. So that's like another option to explore. That's kind of outside Kubernetes, but would also allow you to get the C group path. Just want to raise that as a possible idea.
That sounds quite specific to CRI. Is that right? All right, Cryo. Sorry,
that was a Containerd based feature. But I think like the idea is hooking into the container, kind of, you know, it's kind of like OCI hooks in some sense of getting back container creation events, right? And then getting the OCI spec and extracting the C group path from that.
Okay, that probably sounds similar to the second approach where we might have to elevate privileges and stuff.
Yeah.
Anyway, I guess it's not a generic enough solution, right?
Yeah, it would be specific to.
We do intend on supporting NRI and Cryo eventually. We just don't yet. Also, as a note.
Yeah, maybe it sounds like for me, I would say I would be very cautious about having kubelet to Kube API server write traffic be expected to keep this data field up as a source of truth for you as a CNI provider that is meaningful and not racy, and would prefer that we find a path to allow you to get this information local to the node without needing elevated privileges. And it sounds like on this call, maybe his next steps, like I'll throw your name out, Peter, but Peter and I forget the gentleman who spoke about Containerd, maybe the three of you could get together and see if there's an alternative path that hadn't been looked at that could be cross runtime portable. But also I was trying to look up myself where we create the pod sandbox right now on the kubelet to refresh my own memory, but it feels like we should be able to do something at that point without needing to rally state back to Kube API. And the more we can do that, I think the better and more narrow the solution is, I guess.
Yeah, I'm not sure if Michael Zappa is here, but he's one of the maintainers on CNI, and he's been wanting to add a couple of extra fields anyway. So he can get together with, David Porter and anybody else who's interested, and as well as the originator of this issue, and we can get this fixed.
Does that sound good? Maybe everyone can put their names in the chat so we can get a group together to do follow-ons.
So just a clarifying question, would the follow-up discussion happen on the issue itself?
That's fine too. I'm just trying to make sure you get connected to the right set of people to help out driving this forward. I think it's personally unlikely that we will want to report this in the Pod API. And so I want to make sure we get the right group of people to know if there's things that can get you the outcome you want without needing us to do that last resort.
Yep. Yeah, Michael Zapp has already made some changes in the cryo and Containerd at the same time to enhance CNI support. So really he's the right guy, I think, to do this one, because I know he's already adding another field or two that we can pass. So the only issue you're going to run into is without going through some kind of a hook mechanism or using what you have now, you have a versioning issue, until this is supported. And that versioning issue would be a, schema change to the JSON that we pass to CNI. That has to be updated, right, and rolled in. And you need the container runtimes to have that version supported. But yeah, we'll tackle it on the issue. I'll ping Zappa there. And Peter and David.
Can I just summarize what we agree upon at least? So we do, I believe, SIG Node do agree. We shouldn't expose this node level, OS level, particularly for Linux OS level of the details to our API server. I think we agree on this one because we have this kind of conversation in the past, right?
Well, it's sort of a heads up here, Don. We're already passing the C group's path.
Yes,
yes. Right up, but we're grabbing it at kubectl.
I just want to make sure we are on the same page because I don't want the personal trend then later come back again. So we kind of already agree on the community, but there's the many suggestion. I think we have the several suggestion. People will write down what their suggestion. So then we can carry on the discussing in the issue and to figure out what's the best to satisfy this. Did I summarize this correctly? Because I don't want people think about later, say, oh, we did agree. So what's the next? We don't agree about the next again.
Yeah, personally, I don't want to expose C group paths in the pod API at both the pod or container level unless I knew all other options were exhausted. And I think my recommendation is that this option, if pursued, would come with other negative consequences that Renal and others raised here. That yeah, if we could just update this issue to say how to best inform a CNI implementer of the pod location, then we would understand the core use case wanting to be solved, and then can find the right outcome for that. That doesn't necessarily lead to a particular implementation approach.
Yeah. Okay, I also personally don't want to, so that's why I just want to clearly say, but I just want to make sure the community also agree, not just personal, right?
So Yonkun brought up a good point in the chat. It seems like with the CRI approach, all the CRI would have to agree on the spec, updated spec. Is that right? And can it delay, or for example, or what if one of the container runtimes don't agree on exposing this field? Would it cause any issues?
Yeah, I think we just need to write down maybe other approaches to solving this to then understand their various pros and cons. But I think there's immediately negative consequences to using this as a stable source of truth value for you, particularly if the thing that's responding to it is running on the node and not running on the control side. If there was a use case that said why the thing had to run on the control side, that would be interesting, I guess, to dive on. But if your thing is running on the node side, then we already need to handle use cases where failure of a kubelet to talk back to Kube API is an issue, how to deal with the write rate, how to deal with a number of other things that can put pressure on Kube API as a concern. So I don't think we know enough on the other paths, but I think everyone now understands the end goal, which should be as CNI providers should be able to know the C group sandbox on a Linux host for a pod in a stable manner. And right now, this approach is one possible approach, but it has negatives. And I think right now, Don and myself, and probably Renal, would say like, we wouldn't want to go this route yet before wanting to look at the other approaches. And because we really do not want to punt the pod C group information in the end user API.
I wrote the summary in the meeting notes, so I think we are next.
All right, so then if everyone else who spoke up on this that wants to help close the gap could put their name in the meeting notes as well, then we could do a follow-up, see if we have names there now, so awesome. Maybe we can come back in I don't know what your desired timeline was, but maybe we can come back in a few weeks and see if we've moved forward on that with more information. Does that sound good?
Sure. All right. Yeah. Thanks for the discussion. I appreciate it.
Yeah. Awesome. Okay. All right. So the next topic here, it looks like the author is not here, unfortunately. So this was around wanting to move forward with fine-grained supplemental groups controls. I guess probably the best thing we can do is who would want to help move this forward. Right now, the KEP doesn't have any assignee. I personally don't think I'm the best candidate for this.
Maybe you can assign me, Derek. So I made a pass. I see it, but I'm thinking of a couple of alternatives. So maybe I'll post a comment on the KEP and see if we can talk through those.
I will assign you now. Awesome. Thanks, Bernal. Okay. It looks like, Kevin, are you on the call? Is there anything more than just approval needed on the resource management stuff?
Doesn't seem to be on.
Okay. So this is updating the KEP to be in sync with the implementation. I guess, Dawn, are you able to take a quick pass at this since you reviewed this more?
I will. Okay, thanks.
And then Swati, it looks like you have an update on, my memory's poor. What was this? This is
yeah, this is the node resource topology API for NumaWare scheduling work. We had a discussion about this last week, so I just wanted to bring this up again. We managed to get a bunch of approvals on this. The only thing that we're waiting for is your approval from kind of architecture point of view. If you could take a look at that, I think we can get this closed then.
For SIG Arch or for SIG Node, or what is this?
I think from architecture point of view, the direction that we are taking from Node point of view, Dawn approved it, and Tim approved it as well. I just wanted you to take a look and if it's okay to move forward.
Yeah. All right, I'll approve that. This looks like it's
Okay.
to discuss.
Yeah.
Thanks. Thanks for making the updates. I was happy we could unblock this, I guess, now.
Thank you. And the other thing is that we have, this is kind of the Bootstrap PR. The API updates are in a separate PR, and I have the link for that as well. So if people have bandwidth, please take a look at that as well.
And then my memory on this was that this is getting wrapped up into the overall resource management sub-project with...
That's right, yeah. That Kevin proposed last week.
And so are there any other, I see right now we have 2 API approvers. Is there anyone else who wanted to come forward now? Or is that 2 lists pretty much everyone who's come forward to date?
I think Tim has been looking at it, and he took a look at the new PR as well. So I guess
I
it'll
just
be...
see you and Famani in the list of API approvers on here, and I was just wanting to make sure there was if there was anyone else who maybe came forward that wanted to do that as well or not.
Tim also is the API approver, so Tim already approved.
I'm just saying specific to the staging repo, like the 2 top level approvers in the owner's file here is
yeah.
2 Red Hat
Yes.
Yeah.
So if anyone, I think Marcus had showed interest in being a reviewer for this, so I added his name. If there's anyone else who's interested in this, like, we're happy to add approval rights. That's no problem.
Okay, well, I'll just there's a question on there, but otherwise, yeah, this looks good. We'll approve it.
Oh, thank you.
All right. And let's see, moving on. These 2 were quicker than I expected. All right, Bobby, do you want to talk about the CRI health?
Yeah, it's me. So I talked a little bit about this a few weeks ago when I wanted to bring up this topic again. I got a little bit more feedback about it. So to give everyone a little bit context, the idea here is there's a proposal. I'm working with someone kind of more on the operational SRE side that we want to add the kubelet. We want to add a health check to kubelet, like a health Z endpoint. So kubelet already has a health Z endpoint, but we want to add the ability for the health Z endpoint to also report that the CRI, the container runtime, is healthy. So the container runtime today, just for a little bit more context, provides us like a status RPC, and it returns conditions around the healthiness of the CRI itself. And so there's like a runtime ready and network ready conditions that the CRI returns. And so today, getting that information is quite helpful to understand, like, if the container runtime is up and we need to do some type of corrective actions, like, for example, recreating some node or repairing it or something like that, if something's not healthy. So today, the issue is that kind of to do a proper health check, we have to launch crycuddle is what we do internally. We launch crycuddle and see if we can connect to the container runtime, but that's quite expensive to launch crycuddle. It's kind of a hefty binary, and we kind of have to launch it on a periodic basis. And we've noticed kind of some performance degradation because of that. So the ideal thing that we would do is just kind of integrate this into the kubelet health endpoint, so that kubelet's already running, so everything's already in memory, and so we can just ask kubelet, hey, is the container runtime up? And it would just give yes or no. And kubelet already has a health Z endpoint, so this is not a brand new thing. This is just kind of slightly increasing the scope of that health endpoint. So that was kind of that's just a little bit of background context. Sorry.
How is this different than the plague?
So the plague,
the node is not healthy if the plug's not responsive. I was just, which is also trying to interact with the container runtime. Is there something different here that I'm missing?
yeah. So the main difference is that for the if the container runtime is not responding, you're right, the flag would not respond. But then what would happen is like the node would try to report the status right to the API server. But we noticed in some cases that node might not be able to. For example, like there might be disk pressure, some network issues, something like that. So the idea here is we want kind of a local check on the node without any kind of API server connectivity about the status, so that we can, for example, like restart kubelet or restart the container runtime if this health check fails. That's sort of the idea.
Oh, okay. I'm sorry, I missed that. So basically, as like in my systemd or something, I can ask if my kubelet component itself is healthy or not, and drive a restart.
Exactly. Yeah.
And you want to drive a restart if my CRI is not healthy?
Yeah.
How will that fix the problem?
So I mean, it depends on the problem, obviously. So I don't think we'll always fix it, but that's kind of what we do today. We have a health check script actually that we kind of run periodically that goes out and checks. Basically it checks if the kubelet's up by querying the kubelet healthy endpoint. If that's not responding, we restart kubelet. And then we also launch crycuddle and see if we can connect the container runtime. And if we can't connect the container runtime, we restart containerd on our side, for example. So we have kind of this basic health check script that we run periodically. But the problem with it is that it has to continuously launch crycuddle, which is kind of hefty to connect to the container runtime. And ideally we just have like a healthy endpoint we could connect to.
Okay, I'm just trying to make sure I understand this then. So in the case where the CRI provider might be saying they're healthy, but they're unable to actually accept connections, maybe because I don't know, something with that socket is wrong, or maybe
something like that. Yeah, like some connectivity issue, for example, or so something got borked somewhere. So we often see that just simple restart can help remedy things. So that's kind of the context. Yeah.
I agree with simple restart. I was just trying to see if it would actually fix the thing. So I trust you. Yeah. Fixes your thing. Is this something Mernal or Peter you would see benefit for with other runtimes, or is there a situation where this makes sense?
Yeah, I'm trying to think of like internally if we've hit situations where we would want this, usually because putting the red hat on because our nodes there's less like manual touching on them, so if something goes wrong, then the admins have to go in and do some management. So I could see it being useful, but I haven't thought of a specific use case that we have internally that we'd use it for, but it'd be easy to implement. So I'm not opposed to it.
And this is already, just to be clear, this is standardized across the container runtimes. Like they already report conditions around the healthiness of them, right? So if you ask the container runtime, hey, give me those conditions, that's already implemented in the container runtime. What's not implemented is there's no simple like HTTP healthy endpoint on the container runtimes or on kubelet to actually get that status, right? So that's kind of the proposal here. It's basically to extend the kubelet healthy endpoint to just report back that information from the container runtime.
And specifically, you're talking about the connection between kubelet and cry, not some new connection that you would make with the client.
Exactly. Yeah. This is the existing container runtime connection. Yeah.
That's fair. And I guess his earlier question there is, what do you want to do if that happens? That sort of changes things, right?
Makes sense. Like for our use case, we just wanted to restart things, but I could imagine we might extend in the future, for logging, for like there could be more action taken. We could report that condition down to some other systems, right? That could do some type of remediation or something like that. Yeah, and so like the last time we brought this up, just to kind of give a little more context, like there was kind of two pieces of feedback. One was like potentially if this makes sense to integrate in the container runtime, not the kubelet. That I think was decent, was pretty good feedback. We kind of looked into that a little bit. So the issue I think right now is that's not standardized across the container runtimes. There's no health Z kind of on the container runtime side. So something we could bring to the container runtime community, I suppose. But the other issue is that it doesn't really show the connectivity is working, which is something we wanted as well. We actually want to check that Kubla can actually make that connection to the container runtime, not just ask the container runtime directly if that connection's up. So that's
just to confirm on this, you're not asking for a new status check. You're asking for the current known status from Kubernetes.
Exactly. Yeah.
So that would be that's a lot faster then. Yeah.
Exactly.
I don't really have any downsides on this, David. I was just trying to think, like, does this actually fix anything? And then, like, right now we don't really do much of anything in a health check on the kubelet process. And so I was trying to think through, like, where we inline C advisor, is that more likely to wedge, like, of the things that we actually dep rather than communicate out to? The only thing I was trying to think where this would help is when if for some reason the kubelet process, due to some bug in the kubelet process, is unable to establish a connection via a valid socket, right?
Or a timeout and got a disconnect.
Yeah.
I mean, we've seen, especially like in throttling cases, sometimes when things get kind of worked, like there's really high IO latency for some period of time, things can kind of get wedged periodically, and like can restart kind of helps clear things out. We've just seen that in production. So that's one of the common cases.
Let me add something. So in the history, Kubernetes did this before even. I just want to say what David request, actually it is something we changed, but it's nothing, but just moved to the different component. So in the older time, Kubernetes detect of the container, which is Docker, is not responsible or it is bad, then we will restart. Even Kubernetes might restart the Docker in a really old time because Docker is really unstable, always unresponsive. So we end up thinking of Kubernetes is the brain on the node. So have to decide, okay, he have to restart a certain thing. So, but that's obviously not a good thing. So then we move that logical out to the system D, some people, and some is like in their startup script. So then later we try to move to this NPD. The problem is even for the load problem detector, just like David said, there's the certain cases which is unnecessarily complicated, and also certain cases we didn't cover, like for example, like the Kubernetes and to connect to the container runtime. Those kind of things is not connected. So what David asked for here, even today, Kubernetes still report container readiness or not, even it's useless to report that kind of, but because we are not really report anything except of the connectivity to the container runtime. But that's not in the endpoint. So what David just say, okay, another way to surface this to the Kubernetes, current Kubernetes, that the container D, it is workable, is connectable, available or not. So I do think about that's not to really add anything additional information, and also clean up, more standardized, and clean up the current cases.
Yeah, I have no problem with this, David. The only thing I was just trying to think through is, like, would we benefit from also having the stats provider being added in the health check or not?
And that's, I think, actually, so the way that this was implemented currently is that there is a status endpoint on the container runtime, right? And it returns a set of conditions. And so we check, I believe, two conditions runtime ready and network ready, right? Which means that, like, the runtime service is up, but there's other conditions that could be added later, like the image service is up, stats provider, et cetera. So maybe that's something we could make extensible in the future. What exactly conditions is considered ready from the container runtime, right? Maybe that's something we could best configure something.
Yeah, I think like we need to figure out if some operations are taking way longer time or something, right? Right now it's like very basic, just the connectivity. If you want to really know that, okay, it's not behaving well, then maybe some operation took way longer than regular time. That's what we need to surface eventually.
I think it makes sense. Yeah. But I guess the question here is just kind of an initial step of just, is it up? And then maybe we can make that configurable. The set of conditions, right? What is the container runtime up actually mean?
Yeah, I think that's fine. I was just being greedy here, thinking, is there something on the cAdvisor interface that we can also pull for a health endpoint so that we can maybe do two things at once here. So I have no objection to this, but if you know off the top of your head, if there was something on cAdvisor that would be wedging that we could pull from the.
Yeah, for cAdvisor, it's a little bit more on the, like it's scraping, it's using iNotify on the actual C group path. So it's not always connecting to the container runtime socket or as opposed to kubelet. So that's kind of the main difference, I guess.
Yeah, I was just trying to think through like all those messages where it's like I'm thinking of horrific node logs I've looked in the past where it's like the interval 10 seconds can't be met type thing and 20,000 times in a row. It's my memory right now on where in cAdvisor that would be the equivalent health endpoint was a little rusty, so I needed to go check that out. But yeah, I have no issues with this. If no one else has any issues, I don't see a problem. I don't think this needs a KEP or anything. So are we just wanting to move forward with this or?
Yeah. We're just goal was to get feedback. Yeah. I was also asking if it needs a KEP or not, but it seems kind of a small healthy improvement. So cool. Okay. So I guess the only question then, is this something we think we should introduce? There was a question around like, should we make this configurable around what type of conditions are considered healthy from the container runtime? In the healthy endpoint, or should we pass maybe the healthy endpoint can take as input the conditions you want to be considered healthy? That's another option. Is that something we want to do here, or should we just stick with the static list of basic conditions? I think that's the only question that's left.
Well, if we start off by just returning the runtime status, whatever it is, like either we couldn't get one or here's what the runtime said, then a client could parse that. And then if we wanted to extend it, we just have to extend the number of conditions that the runtime can send.
What does the network ready condition tie to right now on the runtime API? If we all got a refresher, like runtime ready, I get, is network ready meaning I have a configured CNI on the host, or what was that tied back to?
Successful CNI. Yeah. On the last updated CNI config success.
So what happens for nodes that didn't yet have their CNI deployed? Does the kubelet always restart? That would be something I wouldn't want to have happen.
Yeah, that makes sense. I think maybe network ready is not something we would want for restart, for sure, right? So let me look into the number.
It sort of depends. I think it depends. If the configuration is there and it's not started, that's a different piece of information.
You still need your daemon set to come and configure the CNI, right? So
yeah.
Well, I'm just a little unclear. Is the proposal now to have this healthy for the CRI then cause the kubelet to make like an intelligent decision about what to do about it? Like, Derek saying it shouldn't be restarted on network not ready. Like, is the kubelet making that decision, or is this a third party?
No, it's third party. I'm
basically like.
Oh, okay, yeah, right.
So Peter, it'd be like, what would we recommend to the community for as the system D unit for the kubelet that integrates with this health check? Like when should
Gotcha. I would almost have it be the unit for the runtime. Basically, I think the manager of the runtime should be the one listening for this to keep a separation of responsibilities, which was going to be my point. But if the kubelet isn't going to have anything to do with it, then that's okay with me.
But this is saying if the kubelet can't communicate to the runtime, then the kubelet should not be considered healthy, which would mean the manager of that would then decide, maybe I'll restart the kubelet. And that's why I asked earlier, what would that solve? And so I was trying to think through that error case. And so if it's like a bug in the client library that talks to that socket, for example, maybe that's what's being fixed. And I trust David that he said he had use cases where this helps. I was just sometimes jiggling the handle helps a lot of things, but we didn't know the root cause. And so I just didn't know if we knew what that was here. But if this would make like many unit files in the world that run kubelets, have kubelets be restarting because the CNI was not yet fully deployed, I'd be hesitant on that one.
Yeah, it makes sense. I don't think maybe probably the network ready is something we would consider then. I think just runtime ready is probably where we would start. And then if we later add more conditions to the container runtime, we can go back and revisit that health check. Maybe that's a good start.
But David, even like today we have the container not ready. We only basically add the Kubernetes start off point, right? So with this change, we basically have the periodic check, right?
Yeah. So the idea here is, for example, for us, we already have a systemd unit that does a periodic health check, right?
Yeah.
But it uses cryctl, for example, to do that. So the benefit here is we don't need to load in this big binary every kind of health check interval, right? And just use something that's already running.
Yeah, so I think if I'm looking at what's on here, network ready is saying the runtime network is up and ready to accept containers which require network. That would be a non-starter for many of my customers' use cases or users' use cases, because the network is delayed. But
Makes sense.
runtime ready seems perfectly fine.
Okay, makes sense. I think we just need to remove the network ready and stick with runtime ready.
Okay.
Cool. Yeah, thank you all for all your feedback.
All right, excellent. Well, I think the last topic here was Vinay's updates on PRs for the in-place resizing, so I think that's fine. Any other things that folks want to raise in the last 4 minutes? Otherwise, thanks all for a great list of topics today.
So for the in-place resize, I think we're just targeting it for 127 now. And I'm hoping that we can merge the API really early because we need that for enabling some of the CI tests. And I'm working on getting the full job fixed up so that once that passes, we know that it's passing with the latest container.
Okay.
Okay, I'll be on vacation for the rest of December, so I'll meet you guys in January and have a great vacation, have a great holidays, Happy New Year.
Yeah, same to you as well, Vinay, and everyone else on the call. So if there's no other topics, then we will end today's meeting, and everyone have a great rest of your day. Bye, everyone.
Thank you.
Hey, Mac.